number 3, a suspicious-looking man. Justin.
Why am I suspicious?
I don't know. There's no reason. I just wanted to pick on somebody. Oh, I'm sorry you're feeling. I apologize. All right. Let's see. A suspicious-looking man runs as fast as he can from one end of a moving sidewalk at the airport to the other in 2.5 seconds. Then security agents appear, and the man runs as fast as he can back along the sidewalk to his starting point, taking 10 seconds. Why did it take him longer to go back? Because he's running against the thing, right? What is the ratio of the man's running speed to the sidewalk speed? All right, so here's the sidewalk. Would you like the sidewalk to be going up or down?
Left.
Not a choice. Here's the velocity of the sidewalk. All right, now the man is going to run with some velocity. The velocity of the man. Now, because he's on the sidewalk, suppose the dude can run at 4 meters a second. 4 meters a second, 4 meters a second, 4 meters a second, right? Then he gets onto the moving sidewalk. He's still running at 4 meters a second, but that's 4 meters a second relative to the sidewalk. Follow?
Yes.
So this velocity of the sidewalk is relative to the ground, right? Cool? So chunk A, when he's going with the sidewalk. All right, so we need to, I feel like we should come up with an expression for the distance, right? So let's just call that displacement, right? So our displacement that the guy is going to run is the constant, right? Because regardless of which way he's going to run, the sidewalk is still the same length, right? So we're talking about the displacement of the man relative to the ground, right? If the sidewalk stretches for 10 meters, that's 10 meters relative to the ground. Good? So let's see if we can write an expression. So this is equal to the velocity of the man relative to the ground times the time, which was 2.5, right?
Yes.
Okay? So that's when he's going with the sidewalk. So let's see if we can write up an expression for this. So the velocity of the man relative to the ground. So the sidewalk is going this way, and the man relative to the sidewalk is going this way. So this is the combined velocity of the man relative to the ground, right?
Yes.
So this is the velocity of the man relative to the sidewalk plus the velocity of the sidewalk relative to the ground times 2.5. That's the displacement of the man relative to the ground. Everybody good there?
Yeah.
Does anybody have any questions? Is anybody lying about their level of questioning? Or things? That was a horrible sentence. All right, now let's do chunk B. Against the sidewalk. Popular Bob Seger song. God, I hate him. All right, so now the displacement of the man relative to the ground, it's still equal to the velocity of the man relative to the ground, but now it's times 10 seconds, right? Follow? All right. So now the velocity of the man relative to the ground is what? Velocity of the...
Man minus that.
Yeah, so this is the velocity of the man relative to the sidewalk minus the velocity of the sidewalk relative to the ground, right? Times 10. Now let me pause for a minute. I know that it's got to be this way, that it's got to be man minus sidewalk, just by doing a little bit of logic. Why? What do you got?
He would never get there if it was overpowering his speed.
Good. He's got to be going faster than the sidewalk or he'd never get there, right? So the velocity of the man relative to the sidewalk has got to be bigger than the velocity of the sidewalk relative to the ground. Follow? Mathematically, this is just, well, yeah. Okay, so good? All right. Now this is all equal to the displacement of the man relative to the ground. All right. So I haven't solved this problem since last year, so I kind of just followed my nose here. I just kind of said, all right, well, I know regardless of which direction he's running, the displacement has to be the same. So what I did was I wrote an expression for the man's displacement in terms of the two things that I wanted the ratio between. And then I did the same thing for the other part. Follow? Carla? I'm not done, but are you good up to there? What do you got?
Yeah, should the
You guys, Patrick, computer.
should the negative VSG, I don't know why, but I have it as negative VGS.
All right, so let's see if we can logic our way through this.
Can you go back up to the top and hit all the V?
Here. Wait a minute. I think this is everything I've done for this problem.
Oh. Because that's fine, never mind. I'll figure it out.
So I think what's confusing about this is that technically this VMS represents his speed. Do you know what I mean?
Yes.
And so I sort of had to inject this negative sign to indicate now he's going the other way.
Oh, okay.
Do you know what I mean?
Yeah.
Follow?
Yeah.
So a lot of this was just kind of some logic, I guess. Everybody good? All right, so now let's solve this mess. So I've got VMS plus VSG times 2.5 equals VMS minus VSG times 10. What am I looking for? What does the question want to know? The ratio of
The man's running speed to the sidewalk.
the man's running speed to the sidewalk's moving speed. That's what I'm looking for, right? So how should I solve this thing? Anybody have any ideas? Yeah, I mean, basically we want to get all the VMS on one side and all the VSG on the other side, right?
Yep.
So you can distribute, which totally works. It's not how I would do it. Because isn't 10 a multiple of 2.5?
Yes.
So let's divide both sides by 2.5. Oh, that's not what I wanted to do. I mean, yes, I wanted to divide. I didn't want to extend my page. So if I divide both sides by 2.5, you get VMS plus VSG equals VMS minus VSG times 4. Now we can distribute. Does that make sense?
Yeah.
So now I've got VMS plus VSG equals 4 VMS minus 4 VSG. Now what? Let's add VSG and subtract VMS. So you get 5 VSG equals 3 VMS. Follow? So let's see, I want to divide by VSG and divide by 3. So you get VMS over VSG equals 5 over 3. Peter.
So the way that I did it was I just like assigned arbitrary numbers to like his speed with like when he's going with the sidewalk and the speed when he's going against it, or his velocity when he's going against it. And
Wait,
then
rewind and say that one more time.
I just like assigned two numbers to his like
What two numbers did you use?
4 and 1.
Okay. And tell me what the 4 and the 1 represent.
4 is like 4 meters per second is his velocity with when he's going with the sidewalk, and 1 meter per second is his velocity when he's going against the
Okay,
sidewalk.
you can't do that.
I got the right answer though.
Wait, you can, because like,
Because you know that like the in the middle of the like in the middle of those two numbers is the velocity of the sidewalk. Like because And then the difference is the velocity of the man. So the difference between the average of those two numbers and the two numbers is the velocity of the man. And then you can
I
take
see
the
what you're
ratio
saying.
of those two.
Okay. Yeah, I guess that works. Yeah. Okay, I see what you're saying. Yeah, okay. That's cool.
But that's what we were talking about. I just like
Gotcha.
wanted to run it by you.
I thought it was pretty cool.
Yeah, that is, yeah.
It could be like two steps.
Cool.